Let's look over the warm-up. So when I asked you to go talk today, try to use more of these, more of the I noticed, more of like, so what I think you were saying is the paraphrasing. You can obviously agree and disagree because some of you are going to have different answers. Support that with the because and then your reasoning. So here are some equivalent equations. Before we start the talk, what is an equivalent equation? What does that mean to be equivalent? Ashton, what does it mean to be equivalent?
The same amount.
Yeah, equal, right? They're exactly the same. They're equal to each other. So if you look, all of these, Jayla, can you put that up on your desk? All of these are equivalent to each other, meaning this is equivalent to that, that's equivalent to this. Doesn't matter what order I put them in, they're equivalent. So these are all multiplication. Talk to your partner about why these are equivalent. Go. And what's making them equivalent. Talk to your partner. Use those ways to talk. Look at Schmitty. Talk to Schmitty. Justin, why don't you move up with Addie today? Jayla, participate with those two. So I was listening to what Dylan said. Dylan and Callie were talking, and Dylan's like, yeah, I agree with you too, because if you switch, if the negative switches, it's still one negative factor. And I know multiplication, I can take A and B and switch them. What do we call that? What? Commutative property. I can switch that, that's the commutative property, and then moving the sign doesn't change my answer because it all has to do with negative factors. Odd number of negative factors, negative answer. Even number of negative factors, positive answer. So these are all equivalent to each other. Now, this is a little different. Division is different. Talk to your partner about this. And what do you notice about this? Use those ways to talk.
Just swap switch. They just like switch. Mr. McFarland, could you say switch or no communication?
Not on division. Can't use because that means commutative property. And that's not what's happening here. I'm not switching the order of the numbers.
Oh, okay.
Up here I did. See, look, there's negative A, there's negative A. There's B, there's B. So yeah, this is commutative. I heard a number of you say this is not commutative. Yes, division is not commutative. I can't take it and switch the values back to front, right? Or the order of the values. Doesn't work. But division, if I have negative A divided by B, that's equal to A divided by negative B. And that these also equal this. And they're the same. That A divided by negative B, A divided by negative B. These are exactly the same. One looks like a fraction, and one looks like an equation. But they're the same. They're equal to each other. So now that you guys know that, write an equivalent example, and you can use these, but you obviously have to substitute in the values, okay, for each one of these. There are two multiplication, and then there are two division. So your job, write an equivalent, an equation, plus then solve it. Okay? Go for it.
Paper thing. Dad, what have you done here?
The sheet?
Yes.
I think Miss Frizzy had it. I did.
Oh, you did.
Okay. So equivalent example. Lots of different ways I could write this. You can see all the different ways. If 7 was A, it could be in the front, it could be in the back. I can change the value, but not the absolute value. Okay, as long as the other answer changes. So here I went with 7 times negative 6 equals 42. Because in multiplication and in division, it's almost like the numbers, when I do the division multiplication, it's almost like they're positive. But then I have to look at how many negative factors are there. Is it a positive answer or is it a negative answer? Here, negative 2 times negative 13, an equivalent would be 2 times 13, because a negative times a negative is a positive. So I just kind of showed you that to make sure you guys understand that. Here I have a negative 99 divided by 33. So what did I do? I switched the signs. I left it with one negative factor, just like here, but I went with a positive 99 divided by negative 33. Answer is still negative 3. And the last one, we have a positive 10 divided by a negative 5. I went negative 10 divided by positive 5 equals negative 2. All of those are equivalent equations. Okay, and so it's really important to understand that equivalent equation just means that your quotient, your sum, your difference, or your product is the same. Okay, and with multiplication and division, nothing changes. We do know that the algorithms for division are exactly the same as they are for multiplication. Questions about any of this?
No.
Okay, turn to page 68 in your math journal. We have to go over the homework because we had some confusion there, or we had enough confusion. Okay, so you can see up here, make sure that you check your homework as we're talking about this. It says you have located fractions such as negative 5/7 on a number line. You have also used fractions to show division. Negative 5 divided by 7. That shows division. Which, just like we said, these are equivalent. Negative 5 divided by 7. And there's one negative factor here. There's one negative factor here. These are also equivalent. In that this is equivalent to those. So all of those are equivalent. That's what we talked about. Tell whether each statement is true or false. And then you notice this part, it says explain.
Oh, no.
So this, I want you to talk to your partner. Go to your homework. We are going to share our examples with our homework because it's going to lead to a lot of good discussion about why. Remember to disagree, agree, I noticed that, another, or what you're saying was, what did you mean by? Okay, use all those sentence starters to support your conversation. Go ahead and talk about A.
That's equivalent because each of them has one negative.
You see it now?
Yeah.
I messed up.
Okay, well, talk to each other. What was your thinking? Where was your error? Because you said they were false, right? Okay, but it's not false. Why is it not false? Why is it not false?
Yes,
I said false.
Yeah, they are equivalent. Okay, so let's come back here. So here, this right here is a negative divided by a positive. Because we know that although these say multiplication, we can substitute that with division and it equals the same. It's going to equal a negative. So this is negative 0.5, right? That's 1/2, 0.5. So we have negative 0.5. Here we have a positive divided by a negative. What does it equal? Negative. So if I was to take these negatives away, I have 0.5 and 0.5. But because one negative factor, negative 0.5, negative 0.5. That's true. That's a true statement that those are equivalent. Talk to your partner about B now. Go.
Okay, that is like super tricky. How is that not the same? Negative 1 is this. That is saying like that whole number is negative.
Yes. But what's a negative divided by a negative? Boom. Boom shakalaka.
But wouldn't that be the same?
No.
Because that's...
No. All right. Let's come back together here. Great conversation. So we had a lot of misunderstanding on these, and this is why I signed it, because I was hoping part of doing your homework, which all of you almost did in here, which is awesome, is that now you have this, like, some of your misconceptions turn into your best learning. And so when you go home and you do it, didn't take very long, but you come to school prepared to either confirm your understandings or have your understandings proven wrong, right? And then to learn the right way. So this is, when you see a negative in front of a fraction, it literally means negative 1 times that. So anytime I take a negative 1 and times it by a positive, it turns into a negative. So this is negative 1/2, or half, sorry. Negative half. Just like it was over here. This and that are equal. But these are not equal. This does not equal these. This, because it's a negative 1 divided by a negative 2. What's a negative divided by a negative? Positive. This isn't a negative 0.5. This is a positive 0.5. Because remember, I can rewrite this equation like this. I can write it so it looks like negative 1 divided by negative 2. And now you're like, oh, it kind of shows up more like a negative divided by a negative. But these are the same. So that's positive 0.5 and that's positive 0.5. Oh goodness, it didn't follow me. That's what I was talking about. You can pause the video at home and subscribe. All right. So, all right. Okay. Any questions about the homework? Okay, put that away. Get your notes out for today. 3.3, division of rational numbers. Okay, to start off today, go ahead. Talk to your partner about what you notice on 3.3. Go.
Are we talking about the algorithm?
Sure, whatever. I mean, what do you notice on 3.3? Is that a yawn?
What yawn?
Just pinch her, Schmidt. No, don't do that. That'd be bad.
And then these. I'm gonna try those problems.
I'm gonna know.
Okay, one thing we noticed. Eli.
I noticed that in the first box, it's pretty much the same thing as multiplication, but it's very simple.
Yeah, exactly. It's almost exactly the same, right? Just a different, instead of multiplication, it is division. Okay, what else did we notice? Ashton.
I noticed that we were dividing whole numbers by fractions.
Oh, good one. Nice. That is over here, right? Whole number divided by a fraction. Bam.
Integers by rational numbers.
Oh, man. Integers by rational numbers. Tatiana hitting it out of the park. Jayla, what did you notice? Okay. Okay, did anyone notice something that you probably learned in 6th grade, or I think it might have been 5th grade?
Oh, yeah.
The copy, dot, flip-flop. Now, the mathematical term for copy, dot, flip-flop is called reciprocal. Okay, so I want you to Gucci flip-flop? That makes no sense.
Okay.
Don't confuse my students. Okay. Okay. Underline reciprocal here and underline reciprocal over there. The reciprocal is when you take a fraction and you flip it. That is the reciprocal. Basically, it means that it equals 1. Okay, if I was to take a fraction and multiply it by the reciprocal, it equals 1. So, you can see over here, here is my copy. So I call that copy. Take these notes. And then this is my dot. That's my multiplication symbol. And the reason why I'm doing copy dot flip-flop is because I have a fraction times or divided by a fraction. Anytime I divide by a fraction, I need to take the reciprocal of it. And then this and that, and I want you to connect those, this is what we call our flip-flop. Let's take those notes. So I have my copy, I've got my dot, and then I have my flip-flop. That's the reciprocal is the flip-flop side. So you can't really divide by a fraction. So what we do is multiply by the reciprocal. And it's way easier. Like so much easier. Because multiplication, we just multiply straight across. So here, it would be 3 times 15, which is negative 45 because it's a negative 3. And then it's 25 times 2, which is 50. So the fraction I would get is negative 45/50. That reduces by 5 to negative 9/10. Over here, another great example. You have 5/8 divided by 1/2. So this over here, Schmitty, I can't divide by that fraction, so what do? Copy the 5/8. So this is my copy. Okay, there is my dot, and there is my flip-flop. So, and then you can see it's the multiplication straight across, and then I get an answer of 5/4 or 1 1/4 if I was to reduce that. This is positive because I have a positive divided by a. I have a positive divided by a positive. Okay, this is what I'd like you to do. Come up here and try these problems. Okay, and you can work with your partner. Go for it.
We go up on the board?
No, just right there on your sheet.
I got all of them. So the top one is, I got it. I'm gonna let you solve it because I'm not This is what? Mr. McClellan, is it negative 8 divided by a half? Negative 5.
Wouldn't this one be negative 15?
No, do the copy dot flip flop.
Oh my gosh, okay.
Come on, take the reciprocal. Take the reciprocal. Yeah, you got to answer them, man.
Okay.
Okay, so my first answer is negative 3 because I have a positive divided by a negative. 15 divided by negative 5. I got one negative factor. I get a negative answer. I have one here. I have a negative answer. I don't have a negative factor. I have to figure out what n is. So I ask myself basically, what is 8 times 8, negative 8? Negative 64. And then if I put negative 64 in, negative 64 divided by 8 equals negative 8. So that's my answer, negative 64. Here, it is using the reciprocal, that copy dot flip-flop. I copy the 30, I put it over 1, because it's a whole number. So I want to turn it into a rational number. Then I do my dot. And now I take the negative 3 divided by negative 6 and do the reciprocal. So I get negative 6 divided by negative 3. A negative times a negative is a positive. I put a positive there so you remember, like, oh yeah, that's positive. And then a positive times a negative is a negative. So now I have a positive divided by a negative, so that gives me my negative 60. Okay? You guys will need to be using the reciprocal today. If you have questions, okay? No, I'll be coming around, but yeah, you can catch me. I'm just going to take attendance and then I'll be out with you guys. So you need to be on page 61. Follow the board because we're not doing some of the questions today. Some of them we'll move on to tomorrow for various reasons. A all, C all, D all. And then this one is the math rubric.
Wait, so it would be A, then
A, C, D, G, B. But you won't get to B today, I guarantee you.
Why couldn't G be A, C?
Because that's the order I want you to do it in. I don't want you to do B unless you get to it today. But tomorrow we're going to start with B. Close.
Yeah, that was actually like.
Just try to follow the order.
Actually, that was actually legit. Like, he asked me and.
Okay, guys, I want to be able to hear the. You can absolutely talk to your partner about math.
Six plus 6. Yep.
No. A all. C. Get B. We'll talk about B tomorrow. I couldn't prepare you guys for all of it. Planner no pass. No. Planner no pass. Oh, it is right. Oh, yeah. Because what's great about when you do 9, you just do 10, right? And then subtract whatever. It's tricky. We'll do it tomorrow. Nice. Because the negative times the negative equals up. Right, so that had to be negative 12. Remember when you're on C, so here for C, make sure on C1 you're comparing the group. And they want you to kind of think about the algorithms when you're comparing the group. Set it up totally correct. So you get your 108, you're trying to figure out how many times 9 goes into 10, right? So your only mistake was 9 goes into 10 how many times? You put your 9 under your 8. Your 9 needs to be under your 0 because you're asking how many times it goes into 10 out of 108. So then you go here, right? You subtract, you get the difference of 1, which is smaller than your quotient, so that's good, right? So now, I'm trying to figure out, so I bring down the 8. Now 9 goes into there how many times? 9 times what equals 18? So, answer is 12. But it can't be just regular 12. It's got to be negative 12 because you already have, right? It's negative times a negative equals a positive. You have 12, that would be a negative 1. Make sense? So remember, it looks like this, right? That's a cool one. So they write it like this, which also equals that. So then also equals, that's negative though, right?
Yeah.
Which also equals,
Oh, no, that's not.
this, and this are all equal.
Yeah.
Top dog goes in the doghouse. Yeah. How many times is 9 going to 4? How many times is 9 going to 45?
That's what I asked you.
Does that make sense, Ashley?
Yeah.
Like every single one of those are equal. It's like fractions can always be written as equations.
What are quotients?
Answer to division problems. So yeah, anytime it asks you for a quotient, right, in C2, right, it's asking you to do the division. So a quotient is an answer to a division problem.
Okay.
Papi, focus. Yep. We got all the quotients right. It's good. It's work. Quotients. 12 is right. Oh, you're just getting on C. Okay. So, what's common here? So you just write group 1. What's common? Think about the algorithms. Think about the algorithms. All positive. Boom, happy. So, here, what's common? Group 1. Think about the algorithms. They are all what? They're all positives. Bam. So you have all positive answers, all negative answers, and all positives. This isn't 9 divided. Remember, this, Justin,
4.5 divided by 9.
this turns into this, right? Which then turns into top dog in the doghouse. That. So it's not 4.5 divided by 9. It's 9. It's 4.5 divided by 9, not 9 divided by 4.5. It's not 2, it's 5.5. Does that make sense? Now remember, that's a common mistake that kids make, is which one positive or negative.
How would I do this? Would I do like as the same
Okay, sure. Yeah. So what you do is you would go 4.5 divided by 9, top dog in the doghouse, so that equals 9. On the outside, 4.5 on the inside. I'm going to my decimal. 9 goes into 4. 0. 9 goes into 45. How many times does 9 go into 45? Just getting ready to do the whole 5. I mean, because you can do that, right, with 5. So, this equals 0.5. So, another way I can write 0.5 is 1/2, right? I can't tell what's G, what's H, what's... Come on, girl. This is like the one part I want you to work on the most, is how you organize your work. So when I come by, I can look and help you.
4.5 divided by 9. That I don't get that dividing decimal.
Okay, well, look over here, Austin. Okay. So, they're asking you 4.5 divided by negative 9, right? So we're going to think about equivalent equations. This also equals this, Austin. 4.5 divided by 4.5 divided by 9. So it equals that, right? So when we write it as a fraction, then we know the top dog goes in the Dog house. So top dog in the dog house. So now this is also equal to this. 9. On the outside, 4.5 divided by 9. We know we write this way. So now I can figure it out because how many times does 9 go into 4?
0.
How many times does 9 go into 45?
5.
So 4.5 divided by 9 equals
0.5.
0.5, which is what? What's 0.5? Half. Now is this positive or negative?
It's positive because it's a positive divided by positive.
Okay, because it's positive divided by positive, that's positive. So do you see this, Austin? Now that this, those are equal. Because look, how many times does 4.5 go into 9?
A half.
2 times, right? That times 2 equals 9. This, how many times does 4.5 go into 4.5?
1.
1. So these are equivalent fractions. Sometimes you see that and sometimes you won't.
Okay.
Okay, now I get to come back to you and check your work. Oh, isn't good? That makes sense. Okay, and then C.
C is almost stuff I This is.
You need to work on the organization.
I know.
You know, but then you choose not to.
But yeah.
Yeah, Organizing your thoughts in math is almost just as important as getting the right answer. Because then your process becomes more evident. Good, negative divided to negative. This one, you need to think about that again.
5 divided by 2 divided 5.
Because another way to think about it, what's 2 times 3.5? Oh, see? That's Callie. That's what I'm saying. Yeah.
It's
2.5.
That's 7, right?
Yes, that's 7. Yeah. Okay, that looks all pretty good. Okay, now you're on G. Okay.
The only part I
Okay, this is what I'm going to ask you to do. Write the problem.
already did.
But then, oh, I got you. It's here.
Yeah.
So can you do this? G1, G2, G3, so you have a problem. You work your answer, and then below it, G2, problem, work, and answer. Just a little bit more organized around your thinking. So it allows you to go back and check. I'll be right there, Jayla.
Confusing how to multiply. Is that a mixed number?
Yeah, so turn it into an improper fraction.
Okay.
How do I do that?
Don't you have to multiply them?
4 times 2 plus, so what's that going to turn into?
9.
9/4. And then you can do the copy dot flip flop.
Okay. Because that's what I was trying to do. I was confused.
What's up?
So, I'm having trouble with the...
I'm going to do that one. Okay, guys, I want to make sure you can check your work here. So, we're going to talk or review these. Okay.
The ones that bother me. I don't like them.
I do not like them, Sam. I do not like them I do not like green eggs and ham. Okay. So here, we're going to skip to this one. Actually, I've helped a few kids. Does anyone need more help with this one?
No.
Oh, we're good. Okay, we're going to go to that one then. So I have here a mixed number divided by a fraction. Can't do it. First thing I have to do, turn the mixed number into an improper fraction. So 2 1/4. 4 times 2 is 8 plus 1 is 9 equals 9/4. So this turns into 9/4. So now I have 9/4. I'm going to go down here. Divided by 1/2. Now, can't divide by a fraction, so I have to do the reciprocal, right? Another way to say that is copy, dot, flip, flop. So I do copy, dot, flip, flop, which is the reciprocal, and I get 18/4. Now, you guys are good enough to turn this back into a mixed number. So 4 goes into 18 4 times, with 2 left over. So it's 4 2/4, or another way to say that is 4 1/2. Peyton, did that help you? I don't know what's going on with my possessed board, but it doesn't like me.
Do you have like a magnet in your pocket?
All right, guys, back to work. There it is.
Maybe if you just get too close to it.
Check some of your G's here.
On
G2?
I'm on G2. Wait, is this division or multiplication?
Multiplication. Yeah. Yeah. So any time you have two numbers that is separated by like a without a sign, they're separated by like a parentheses to show that number is a number, not an operation, right? But a number, then it's just multiplied.
So then this would be multiplied too?
Yeah. It's multiplication, multiplication, multiplication.
Alright.
Yeah. Yeah. I was just going to talk about it. Okay. Callie brought this up, and she just wanted some clarification. Make sure she was doing this right, Eli, because this isn't intuitive. Otis, is that when I have numbers, like here I have brackets, parentheses. Sorry. So yes, I have to do what's inside here first. But then I have this number on the outside of the parentheses. So what it means is do what's inside, and then this number is multiplied by what's inside. So when they put like here, this is multiplication. That multiplied by that. Same here. Multiply this by that by that. That's just multiply, multiply. So when you don't have a dot, it means multiplication. Any questions?
Nope.
Okay. We will continue work. Can I just see a show of hands on who got the D?
Oh, I'm on.
Okay. We're going to start there tomorrow because I want you to use the writing rubric on that tomorrow. All right. Your ticket out and your homework. 15A through F. A through F. Not very long. So remember, it's more about you guys going home, remembering the algorithms, Justin. Practicing those algorithms. Practicing the copy dot flip flop. Doing the reciprocal. Okay? Making sure you know how many negative factors you have and if it's positive or negative. on 68. So today, we didn't go over this at the beginning, and that's my fault. But you can see we're trying to discover this relationship between multiplication and division. We know that they share a fact family, right? Because before I was showing you, like, you could take negative 8 times it by 8. Oh, that's 64. Boom, that's what I'm missing. So they share a fact family, but now you also know that they share, the algorithms are exactly the same, like Eli said at the beginning of class, except for there's a division symbol instead of a multiplication symbol. And that helps me to determine my solution. So don't get help on these. I want you to do this on your own, because we're going to do a little survey at the end. Give you about 1 more minute to kind of work on these. Remember the relationship here. There's a relationship. Are you Tatiana, you done? Okay. You done? No. Okay, I'm going to give you about 30 seconds because I want to be able to talk about these. Eve, I think you passed on the yawn to me. Oof. Just had coffee too. What's going on? All right. So Addie, just like in our I can statement, there's a relationship, right, between multiplication and division. So how does that relationship help me here? Negative 4 times negative 3 equals 12. So 12 divided by negative 3 equals 4. Negative 4. Thank you. So n here equals 12. Using that relationship between those two, multiplying to find out my n. Okay, over here, we have a 16 divided by a quarter. Okay, 1 over 4. So I have a fraction. Can't divide by fractions. So we have to take the reciprocal, copy it off flip-flop. 16 over 1 times 4 over 1. Okay, that equals, 64 over 1. Okay, I have a negative and a positive, so my answer is negative 64. Negative 64. So this is what I need from you guys. Because I want, and just be honest, because this is how I help you. If this is secure, you got both of them right, I want you to walk over that side. If you got one of them wrong or you missed a piece of them, I want you over on this side. Dang.
Yo, look at this, man. I am alone.
Okay, which one did you miss? The second one. Okay, I'll work with you tomorrow on it. Awesome. Thank you. Perfect. That's all I need to know. Awesome. Thank you, Austin. Hey, that's how it's got to be. I love it. He's honest because now I can help him. Thanks, guys. We'll see you later.